Hello and welcome to your first lesson of the week, which is evaluating the methods to protect against tectonic hazards. What this means is being able to predict, so know when they're going to happen, and also make sure that people do not get harmed against the tectonic hazards. The first thing we're going to do is understand the definition of prediction and planning. Then we're going to explain how we can predict for volcanoes and earthquakes, and then we're going to think about which one of these methods is best. For today's lesson, you will need a whiteboard, you will need a piece of paper, and you will need a pen. Predicting and planning then, you have two pictures to represent what these words mean. Can you pause the video now for 10 seconds and see if you can work it out? Prediction then is being able to say when a tectonic hazard is going to happen next, whereas planning is being ready for it when it does happen. For example, prediction will let us know when it's going to happen, so I think it's going to happen next week, whereas planning enables us to build things so that we have less deaths and less economic damage. What we're going to do now then is watch the video that is attached to class charts. What I would like you to do is say why scientists or how scientists can predict for volcanic eruptions. And then, for mastered, can you tell me the reasons why it would be so difficult to predict volcanic eruptions in LICs? So you're just noting down all the different ways that they say that you can predict for a volcano. Pause the video and watch the YouTube link now attached to class charts. This diagram then shows you some examples that we can predict volcanoes that were shown in that video. For example, you've got sulfur emissions, which show you that there is an egg smell and that horrible gas being released, which is released before the eruption occurs. So if that is detected, we know it's about to erupt. You've got a cryptodome, which is when the volcano has a bulge or a big giant spot on the side where magma has built up and stuck out. You've got ground deformation, where the ground changes shape as magma rises and pushes it out. This can be detected using a tilt meter. And you've got seismology, which is the earthquakes that occur on the volcano as the magma moves the ground underneath. For developing, I would like you to tell me which one of these methods you think will be the most useful in LIC and why. And you can write this on your whiteboard. For secure, I would like you to think of a problem for each of the methods. Why are they not perfect? And then for mastered, you have been given all of the methods. Can you think of a problem with all of them and then highlight the one that you think is the most useful and explain your choice? If you really want to push yourself in set 2 and 1, or if you want to challenge yourself, can you think of a counter argument to say why someone might disagree with you? Pause the video and answer the questions now. Now we've looked at predicting volcanoes, we're now looking at predicting earthquakes, and this is even more tricky. For developing, you're going to match the method for the explanation, and on the whiteboard you can just write the number and what it matches to. For secure, for each of these methods, I would like you to predict what the problems would be with these methods. And then for mastered, I would like you to tell me which is the best and which is the worst, and tell me why. Here is the matchup. So what I would like you to do now is match the method to the explanation. You can do this on your whiteboards or on a piece of paper. Pause the video now. You have 1 minute. Groundwater then matches with number 3. Water levels rise before an earthquake eruption happens, usually. Animals act a bit weird, number 4. Tilt meters, number 2. As the rocks move, the land might change, and a tilt meter measures that. And seismology is the equipment that shows you that needle that moves up and down when the ground shakes. And usually before an earthquake, there are some smaller shakes, which are called foreshocks, and that will tell you if a bigger earthquake is predicted at a later stage. If you're doing secured, then pause the video and tell me a problem with each of these methods. And then for mastered, can you do that and also tell me which you think is the best and which one you think is the worst? Pause the video now. Well done for your learning today. To prove your learning, you're going to upload the answer to this question to your teacher. Volcanoes are easier to predict than earthquakes. Do you agree? You need to include a reason, because, and you need to include an example of how both are measured. For mustard, why will this be different between HICs and LICs? This will be needed as a sentence for set 2s and set 1s. Can you now answer this question, take a picture of it and upload it to your teacher? Thank you for taking part in today's lesson, and I look forward to seeing your work.